Selamat sejahtera to our lecturers. This is a presentation for REG 360 Industrialized Building System. We are from Group 13. We'll start the presentation by explaining the design concept and how does this design come about. We approach this design with a contemporary and minimalistic style, perfect for a modern family and a family looking for an upgrade to their house. We finish the design with touches of industrial style. The key influence of this design is the approach of being sustainable, where we try to harvest as much sunlight to the common area of the house. For instance, the stairwell is next to a curtain wall. The staircase takes up a huge space of the house, especially when it's located at the center of the house. If it is well lit throughout the day, it will brighten up the house. This will significantly reduce the cost. We are also aware that the heat gain through the curtain wall, so we utilize the stairwell as a heat buffer. So at the center of the house, it wouldn't be as heaty. We also propose a clear division of public, semi-public and private spaces. We gave each individual room sufficient space and the access to the natural sunlight. Proceeding to the layout of the design, shaded in dark grey are the common area for the family members. The rear end is targeted for the private areas, and at the ground floor it's only for public and semi-public areas like living area and the dining area where the owner could entertain their guests, and at the rear end is the kitchen, and going upwards it's only for semi-public and private spaces where the room, family area, study room and the terrace is located. Here's the technical drawing of the floor plan. The total floor area is 307 meters square with the width of 7,500 millimeters and the length of 14,300 millimeters. The door and window fittings and the column are in compliance of MS 1064, which would be further explained in depth by my friend later on. We also use precast concrete staircase that will be eventually be fitted into the house, and also balcony that is precast to be assembled on site. Next part would be continued by my friends.
The elevation. This elevation for townhouse building, this building that two floor is ground floor, first floor, and second floor. The height of the floor is 5,000 for each floor. The front elevation shows the curtain wall as a main feature for the large glass opening to allow a lot of light into the building, and the side elevations show the nice proportion of the three-story townhouse. The design of the stylish roof gives a building look modern and does not look too cozy at this stage. Material that I use is the front elevation, the right elevation, rear elevation. For the section, show the inside of the house and the many openings make the space look light and light.
Hi, my name is Jean and I'll be talking about the structural layout of our townhouse design. So first off is the beam layout. So all the beams used for our buildings has the same width and height, which is 200 millimeters by 350 millimeters. So this is considered a preferred set of dimensions under the Malaysian standards 1064, which we need to comply because we want to obtain a high score for our IBS scoring later on. So we took that into consideration when we decided on the beam placements for our design. So we measured the lengths of each beam from the midpoint of one column to another. So we did this for all the columns in the townhouse, and that's how we got the beam component schedule, which is in the next slide. So this schedule shows the different types and sizes and the quantities for each type of beam used, and we can see that there's 7 different types of beams, and this kind of coordination is actually a good way of keeping track of all the beam components. Next, we have our slab layout for our townhouse design. So we use precast concrete slabs as our flooring system, and the sizes are also all coordinated to comply to the Malaysian standards. So for all the slabs throughout the 3 floors, We use the same thickness, which is 150 millimeters, except for the toilet pods, which have a thickness of 100 millimeters. So we can see here in the structural plans that there are different types of slabs used, and we've actually used 25 different types of slabs because spaces and the rooms in the house, they all have different dimensions, so we had to adjust to that. But there is a certain floor area for each floor where the layout is repeated. So this is where we utilize vertical repetition, which is something that we learned and come to understand as we went into the part 3 of the IBS scoring system. So the next slide shows the slab component schedule and how many quantities for each type of slabs there are here. And that's it for my part.
Hi, my name is Shahira binti Muhammad Nasir. So I will discuss about wall and column layout. Okay, for wall and column, we complies to Malaysian standard 1064. This is column layout. Column layout, we use 100% precast column. So structure system for column is in situ column with visible system forward. Size of column is 200 times 200, and total column in ground floor, first floor and second floor is 34 detail columns. So we have 3 types detail columns for column 1, column 2 and column 3. So column 1 size column is 550 times 150 and quantity is 12. For column 1 we have two cobble on side faces of columns. For column 2 size length 1300 times 150 and quantity 18. We have 3 cobble on side faces of column. Column 3 we have 4 cobble on side faces of column. Size 850 times 850 and quantity is 3. So this is here about columns. We have to label external wall. We use precast concrete, and then for the part we don't thick for precast, so we use in situ.
So as stated earlier, we are using one type of single flush door, one type of double sliding door, and only one type of double flush panel door. There's 13 units of such single flush door and 5 units of double sliding door and 1 unit at the main entrance for the double flush panel door. All complies to MS 1064. As for the window, we choose one type of window to be used throughout the unit, which is a double swing of 1200 times 1500 mm. There's 12 units of such, which also comply to MS 1064. These are the trusses for the 2 main shed roofs.
I'm Ravindran from Group 13. Today I'll be presenting my part on perspectives. As you can see, which is the exterior perspective of the house. First of all, the main highlighted part of the house I would like to point out is the parking lot, which can fit 2 cars with provided shading, and balcony at the second floor from the master bedroom, together with horizontal louvers which acts as a shading device to control the natural light to get into the house. And this would be the living area and the dining area at the ground floor, which you can see is connected right beside each other. And the interesting part of this area will be the curtain walls, where the users can connect easily with the nature outside. And as you can see, the users can also experience a good view when they use the stairs to go up to the first or second floor. This will be the family area located at the first floor of the house in between the bedrooms, and it's right beside of the stairs, and a good place for the family members to spend a good time together, as well as have a good view to the outside through the curtain walls, and followed by a study room which is located at the second floor of the house. And the interesting part of this area is we have proposed a quiet and a comfortable place for the children to study, as well as there's a window where it's enough sunlight for them to focus on their studies. And lastly, One of the most interesting part of the house would be the roof terrace, where the family members could easily get connected with the nature at the open area. And we have also introduced the vertical louvers, which also acts as a shading device to control the amount of light to get into the house. And it also creates a comfortable area for the family member to rest.